Hello guys, welcome back to Max First Aid. For today's topic, we are going to touch on basic differentiation. Now, one of the reasons why I'm doing basic differentiation today is actually because of one of my students, Kevin. He's about to start on his calculus syllabus next week in Polytechnic, and he do not have the basic foundation in his additional mathematics in his upper secondary years. So this tutorial will be really useful for him. So Kevin, if you are watching this video, please pay close attention to it, alright? Now, for basic differentiation, I understand that many of the schools actually teach formulas and rules. I find it pretty hard to understand them when I was a kid. It's a good thing that my mentor taught me a few basic tricks. Now, for really basic differentiation involving some of the functions, she has 3 steps to do it. Okay, so let me just write down 3 steps. The first one is to bring down power. Second, reduce power. The third step, and I'm going to start this one because I'm going to explain later on what the third step is all about. You do not need in some of the question. Multiply by differentiated content. Right. These are the 3 steps. Okay. So without further ado, let's start a few questions to see how we are able to apply it. Now, the next few questions basically are just going to do a differentiation on the following expression. The first one is I want you to differentiate this 3x with respect to x. Now 3x, the power of x is actually 1, right? So we are going to apply the first 2 steps. The third one is not necessary because this is not a linear functions involving power. No, it's just something really simple. 3x to the power of 1. Apply the first one is to bring down the power. So I'm going to bring down the power of 1. So 1 dot 3x. Now I'm just going to copy down the power of 1 here. Then I'm going to reduce the power, step 2, by 1. So if I tidy up everything, it's basically 1 times 3 is 3. X, 1 minus 0 is 0. So as you know, x to the power of 0, anything power of 0 in fact, is just 1. So 3 times 1, 3. That's the answer. Pretty straightforward, right? Now moving on to question 2, you're going to differentiate x cubed. So likewise, I'm going to apply the first 2 steps, right? 1 and 2. I'm going to bring down the power, 3. I'm just going to copy this down. I'm going to reduce the power by 1, right? I'm just going to tidy up everything. 3x squared. And that's the answer. Very straightforward. Now another thing that I like to take note is that if I'm going to be differentiating things like 4, okay, or if I'm going to differentiate things like 5, like 107, basically differentiating any constant k, I'm going to get 0. Alright, take note of this. Differentiation of any constant ends up 0, gone. Alright, so moving on to the next few questions which I found. Differentiating 4 over x to the power of 4 with respect to x. So how am I going to do this differentiation? For me, I like to express this in this form. 4x to the power of minus 4. Okay, so right now I'm just going to apply the first 2 steps as usual. I'm going to bring down the power, which is minus 4. Then I'm going to copy everything down. then I'm going to reduce the power by 1. Okay, then now I'm going to tidy up everything. It's basically minus 16 x to the power of minus 5. Now in maths convention, we always like to express it in terms of the positive notation. Alright, so you do not want to see any negative power, so I'm just going to rewrite it into a positive index notation, x to the power of 5. That's the answer that we are looking for. Okay, so for question 5 is basically differentiation of this term, 2x plus 5 squared. Alright, so we are not going to use the third step. For those of you who already know what this is about, it's not the chain rule, in case you're wondering. We can basically make it simpler, the approach there, to use any rules at all for as far as the third step is concerned. Just the first two is sufficient. What we do is that we're gonna expand this, so it's gonna be 4x squared plus 20x plus 25. Just gonna expand it based on the a plus b bracket square. I hope you guys remember the algebraic expansion. So this one is just differentiation of the individual term. Okay, so the differentiation of 4x squared, basically 2, I bring it down, right? So it's 2.4x2 minus 1, right? Same goes for the 20x, right? It's actually power of 1, right? So it's just 1.20x. It's copying down 1 minus 1. Okay, and the back here is a constant, so you know differentiation of a constant is just gone 0, right? So if you want, you can just put it here 0. I'm just writing it really explicitly in terms of the steps, but later on, once you get the hang of it, you don't even have to copy down things like that. Minus 1, not necessary. We can go straight to the point, right? So the answer here is basically 8x 1 to the power of 1 plus 20x to the power of 0 and 0. I'm not going to copy it down. Here is basically 1. So it's 8x plus 20. That is the answer. Pretty straightforward, right? Now this concludes the first two steps. The third step is where we are going to see a function like that. Okay. Question 6. So if you're going to do differentiation of 2x plus 5 to the power of 10. So you see, if you want to expand this, it's going to be some problem. It's going to be a really huge term, right? Many terms over there. So what we can do is we are going to apply the third step, which is multiply by the differentiated content. Now what do I mean by the differentiated content? The differentiated content would come from the content here. So I'm just going to apply the first two steps first for you guys to see. So power of 10, right? So I'm just going to bring down the 10 down. So bring down the power, which is the first step. I'm going to reduce the power by 1. So far, so good, right? Now, the third step is basically this one here. The differentiated content, take a look at the content inside the bracket. If I'm going to do a differentiation on this content inside here, which is, let me just take note. If I'm going to do a differentiation on the content inside, I'm going to get what? If I differentiate 2x, I will get 2. If I differentiate 5, it's gone because it's constant, right? So this is a differentiated content, which is 2. So the first step, I've already bring down the power of 10. I reduce the power by 1. The third step is multiplied by the differentiated content, which is 2. Because if I differentiate the content inside here, it's 2, right? So I just need to tidy up everything. 2 times 10 is 20. Okay, sorry, let me copy it down properly. Then everything remains the same, power of 9. That's it. Pretty straightforward. I hope you guys are able to see it. Okay. Let me just start on a new sheet of paper. Okay. Coming to the end here. You just arrange it now. Are you able to see it? Okay, I hope you're able to see this. Alright. So it comes to question 7. So if I'm going to differentiate this expression here, 3 over x plus 4 cubed. Now as you know, I always like to put the expression in this manner. Differentiation of 3 x plus 4 to the power of minus 3. It's easier for me to see. Okay, so if I'm going to differentiate this, I'm going to bring down the power of minus 3. So it's minus 3, not 3. Just copy everything down, reduce the power, and multiply by the differentiated content. In this case, if I differentiate the one inside, I'm just going to get 1. Right? So nothing's changed. So everything is going to add up to be minus 9 x plus 4 to the power of minus 4. Let me change it to the positive index notation so that this one can be reflected as positive power. It's minus 9 over x plus 4 to the power of 4. That's your answer. Pretty straightforward. Alright. Now, question 8. I'm going to differentiate this function here. 5 over 3x to the power of 4 plus 7 bracket to the power of 5. Alright, so same thing, I would like to manipulate it, try to adjust it a little to something that I'm more familiar with. 3x to the power of 4 plus 7 to the power of minus 5. So same 3 steps, right? You're going to bring down the power, which is minus 5. Everything remains the same. Okay? I'm going to reduce the power by 1, and I'm going to multiply by the differentiated content inside here. So let's see. If I'm going to differentiate this term inside, I'm going to get basically 12x to the power of 3. I hope you're able to see it, because bring down power 4 becomes 4 times 3x to the power of 4 minus 1, right? So it becomes x cubed. Alright, so let me just tidy everything. So it's basically minus 25 3x to the power of 4 plus 7 power of minus 6, and then here you have times 12x cubed. Right? So 12 times 25. So if it's 25 times 10, it's 250. 3 times 12, you're gonna get 600. Sorry, 300. I hope I'm correct. I don't have a calculator with me right now, but it should be minus 300 x cubed 3x to the power of 4 plus 7 power minus 6. So I told you before, I don't want to see a negative index notation. I only want to see the positive index one, because that's maths convention, right? So I'm going to express it in terms of this. I'm going to move it down. 3x to the power of 4 plus 7 power of 6. That is the answer. Well, that concludes the end of this brief differentiation tutorial. The next time where we come back, we're going to do differentiation of trigonometry functions, exponential functions, and even logarithmic functions. So please stay tuned. I hope today's tutorial is pretty clear to you guys, and Kevin, please spend some time going through them, alright? Because you're going to need these in your next lesson. Thank you so much.